This is the push-it simulation. So the purpose of this activity is to understand Newton's second law of motion. So I'm obviously going to post the simulation. You can see that is on the right side of the screen. And I'm going to obviously post this video to help you out. And I'll put a couple of links. And you can see off to the right, I did put that equation, which is Newton's second law. So let's just look at the instructions here. So it says use the tables to set the simulation. Then calculate the acceleration of the block in each scenario. Get the velocity of the block after the first 5 seconds from the scenario. Then graph the acceleration versus mass and the net force. So let's just do this first one, right? So let's go ahead and start this simulation. There we go. I have this. Now, it does say in here, in the instructions, that the static friction should be 0. We're not dealing with friction in this one. So it's already set up to the first scenario, the first one, right? So I can go ahead and just click push it, and it's going to push that block. Now, I need to get this one, right? The simulation, I click on that, and you can see it gives me like coordinates. I need to know it after 5 seconds. So there's 50 meters per second. So that's what I can get there. That's going to be 50 meters per second. And I have it set up. Don't put the units. Now, the acceleration, we need to use Newton's second law. The acceleration is the net force divided by the mass. So the net force is 10, the mass is 1, so my acceleration is going to be 10. And you can see here, I did calculate the acceleration of the block, use Newton's second law of motion, and divide the net force by the mass. And you can see it's going to make a nice little graph for you that shows what happens in this first setup where the mass is manipulated, the mass is changed. Now let's go ahead and go down to this second one. Use the first 2 columns in the table to set the simulation, same thing. And this time what we're doing is we are changing the net force. So notice the mass in all of these is going to be 5. So I need to reset it, and I'm going to make the, there it is, 5. All right. Now the first net force, the applied net force is going to be 10. And now I'm just going to push it, right? There we go. All right. So I come in here and define the velocity after 5 seconds is going to be 10 meters per second. There we go. And the acceleration, well, once again, the little hint that gives you that we're using Newton's second law. The acceleration is that ratio of net force to mass, the net force divided by the mass. So you can see that I'm going to take the 10 divided by the 5. So that's going to be 2 meters per second squared. And once again, it's going to make a nice little graph for you that will show you the relationship of acceleration net force. So the conclusion questions ask you questions based on the different graphs. So answer the questions about the state of motion as the block is being pushed. So I can give you little hints there. Just tell me if the forces are balanced, unbalanced, what's the net force acting on the block, and is the block accelerating or not. So these next questions say, well, looking at the graph generated, answer the following question. So the first graph is this one where we're changing the mass. And once you have that graph generated, it says, well, what happens to the acceleration when the when the mass is increased and the net force remains the same, right? So that's what it's asking. You do have choice. So you have increase, decrease, remain the same. And then it says what happens if the object is, or the mass is decreased and the net force remains the same. So that's just asking about the relationship about the graphs. The next one says, well, what happens to the acceleration of the object if the net force is increased and the mass remains the same? And the next one is what happens to the acceleration of objects if the net force is decreased and the mass remains the same. So once again, increase, decrease, remain the same. And the last question just sort of sums it up. In your own words, explain how acceleration is affected by the mass of an object and the net force being applied to that object. So this all has to do with Newton's second law. Newton's second law of motion is written as an equation. According to this equation, what is acceleration? There's a key word that describes what acceleration is according to the relationship between net force and mass. So that's it. This lab is just explaining Newton's second law. So once again, this is the push-it simulation.